Today's video, I would like to introduce you a very nice problem for Yugoslav mathematical Olympiad. Sorry, I don't recognize the year of this problem. So anyway, we have the following information: x, y, z are positive integers. We have this condition. We have the reciprocal of x plus the reciprocal of y plus the reciprocal of z equals number 1. Okay. Our goal, we are going to prove this product, which is x minus 1 is multiplied by y minus 1 is multiplied by z minus 1 is superior or equal to number 8. Okay. In fact, this is not too hard to solve, but it needs a small trick. Once you find the trick, it will be easier to solve. Okay. So the hint that I'm trying to give to this problem, so we are going to make the connection between this one and this one, of course, because they give us this condition in order to prove this one. So that's mean we have to work on this one in order to make a relationship between this one and this one. Okay. Let's go ahead, pause this video if you would like to give a try to this problem. When you want to come back to see the full solution. Okay, let's get into the solution now. So first of all, I'm going to work on this one. So I have this set up 1 over x plus 1 over y plus 1 over z equals number 1. Okay. So for the first equation, I'm going to bring this 1 over z to the right hand side of this equation. Okay, I will have a system of the equation. 1, it will be written 1 over x plus 1 over y equals 1 minus 1 over z. The second one, I will have 1 over x plus 1 over z. The third one, I will have 1 over y plus 1 over z equals 1 minus 1 over x. Okay. By making z as a common denominator, I will get z minus 1 is divided by z. The second one, I will get y minus 1 is divided by y. The third one, I will get x minus 1 is divided by x. So what I'm going to do now, I'm going to multiply both sides by z. Here by y, here by x. So by multiplying by z, I will get here z. By multiplying the second equation by y, I will get y here and y here. The third one, I will get x here, x here. Okay. So now this one is giving us z minus 1, this one is giving us y minus 1, this one is giving us x minus 1. Okay. So now I'm going to make a product, okay, by multiplying this one by this one and by this one, to make a product for the left hand side of this equation as well. So that's mean I will have this one is multiplied by this one and multiplied by this one. I will get z over x plus z over y is multiplied by y over x plus y over z is multiplied by x over y plus x over z. Is giving us this product. I will have x minus 1 factor y minus 1 factor z minus 1. Okay. Now I'm going to make this product, then I move on to the next one. Okay. So by multiplying z over x is multiplied by y over x, I will get z y is multiplied by x squared. Okay. For the second term, I will get z over x is multiplied by y over z. So I will get z cancelled out because one is in numerator, the other one is in denominator. I will get plus y over x. So for the third term, this one is multiplied, z over y is multiplied by y over x. So y will be cancelled out. I will have z over x plus the last term in this product. Y will be cancelled out and z will be cancelled out because we have this one is the inverse of this one. So we'll get number 1 here. This product is multiplied by this product, x over y plus x over z. Okay. Now I'm going to distribute this one. I will have this term is multiplied by this term. So I will have x and y will be cancelled out. I will be left with z over x. In the first term, z over x. For the second term, this one is multiplied by this one. We'll get x and z cancelled out. I will have y over x as a second term, y over x. Okay. For this term, now I'm moving on to this term. So this term y over x is multiplied by x over y is given as 1 because this one is a reciprocal of this one. Then this term is multiplied by this term. I will get x cancelled out. I will have y over z plus y over z. Now I'm going to move over to this term. So this term x will be cancelled out. I will be left with z over y. Okay. Then this term is multiplied by this term. X will be cancelled out and z will be cancelled out because we have this one is a reciprocal of this one. I will have plus 1 plus this term, the last term. I will get x over y plus x over z. Okay. I'm going to group the term and the reciprocal of this term. Okay. So for instance, here in this example, I have z over x plus x over z. I'm going to look for x over z. X over z. This is x over z. I'm going to bring this one next to this one. I will have x over z. For the next term, y over x. Now I'm going to look for x over y, the reciprocal of this one. X over y, which is this one, plus x over y. Then I'm going to look for y over z. I have y over z. I'm going to need z over y. This is z over y. Okay. Z over y. Plus, I have number 1. This I have plus 1 plus 1, which is plus 2. As we know, this term equals this product, x minus 1 factor y minus 1 factor z minus 1. Okay. So I have this expression. Now I'm running out of the room. I'm going to bring this one at the top and continue with our problem. So from the last board, I came up with this expression as a result. Now I'm ready to make the comparison. So I'm going to work on these terms, this one, and this one. Okay. As we know, we have this formula, x minus z quinary square equals x square minus 2 times xz plus z square is superior equal to 0. Okay. This is the form quadratic binomial. So I'm going to bring these two xz to the right hand side of this equation. So I will have x square plus z square is superior equal to 2xz. Okay. So I'm going to divide both sides by xz. So I will have x square plus z square is divided by xz is superior equal to 2. Okay. I'm going to simplify out this one. So I have z over x plus x over z. This one I will have x is multiplied by z. In denominator I will get xz. In numerator I will get z square plus x square. Okay. As we found, this term is superior equal to 2. Okay. This argument follows similarly to this term and this term by symmetry. Okay. So we'll do the same thing here. I will have y over x plus x over y, which equals y square plus x square over x y is superior equal to 2. Superior equal to 2. For the last term, I will have the same thing. Y over z plus z over y equals y square plus z square is divided by zy is superior equal to 2. Okay. Let's call these three terms as a capital A. Okay. So we'll have a capital A plus this number 2 is superior equal to 2 plus 2 is 4 plus 2 is 6. We'll have 6 plus 2, which equals to 8. Okay. So I have proven this one. Finally, I will have A plus 2, which equals to this product, x minus 1 is multiplied by y minus 1 is multiplied by z minus 1 is superior equal to 8. Okay. Now I have proven this one. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.